Hi everyone. Matters consists of gases, liquids, and solids. In previous lecture, you have learned that elements are the building block of matter. Elements consist of small particles that are called atoms. So today, you will be introduced to different states of matter such as gases, liquids, and solids. The synopsis of this chapter introduces the students to the basic properties of matters, such as gases, liquids, and solids, in terms of the interaction, distance of separation, and degree of organization of the particles. Students are also introduced to their applications, in the special topics on environment and health. Basically, there are 6 main topics that will be covered, which are: Introduction, the gaseous state, the liquid state, the solid state, chemistry and environment, as well as chemistry and health. Do you know what is the main property that distinguish gases, liquids, and solid particles? It is the physical appearance. The physical appearance is related to the 3 factors, which are: 1. The distance of particles. 2. The interaction of particles, how the particles are joined together. 3. The organization of particles, how the particles are arranged. Let's start with solid state. Solid state is the most organized, with particles are close together, allowing significant interactions among the particles. This results in high melting and boiling points for solid substances. Why is this happen? Because large amount of energy are needed to break the bond and disrupt the orderly structure. Gases, on the other hand, are disordered, widely separated, and have weak interactions between particles. Their melting and boiling points are relatively low. Gases at room temperature must be cooled at a great deal for them to liquefy or solidify. For example, the melting point and boiling point of nitrogen gas are -210 degrees C and -196 degrees C, respectively. The last one is liquid state. Liquids are intermediate in character. The molecules are close together, like solid. However, they are disordered like gas. All these changes in state are described as physical changes. When a substance undergoes a change in state, it also involves changes in their physical properties. For example, when ice forms from water, changes occur in density and hardness, but it is still water. Now, we discuss in detail, for each state of matter, started with gaseous state. Let's start with ideal gas concept. An ideal gas is a model of the particle's behavior at the microscopic level. Why? It is used to measure their properties, such as temperature, pressure, volume, and mass. We also can systematically change one of these properties and determine the effect on each of the others. For example, by blowing up balloon, mean you are putting more molecules inside the balloon. It causes the volume to increase. This is an agreement with a theory, proposed by Avogadro 200 years ago, that number of molecule is proportional to the volume. Next, we learn on the measurement of gases. There are many gas laws in chemistry, involve the relationships between pressure, volume, temperature, and number of moles. Before this, we are familiar with temperature, volume, and mole. So, now we learn on gas pressure, which is the result of the force exerted by the collision of particles with the walls of the container. Pressure is force per unit area and can be measured with a barometer. The most common type is a mercury barometer. Mercury barometer consists of a tube seal at one end, is filled with mercury, and inverted in a disk of mercury. The height of the column is proportional to the atmospheric pressure. A common used unit is atmosphere, ATM. 1 atm equals 760 mm Hg equals 76 cm Hg. 1 mm of Hg equals 1 torr. Standard 1 atm equals 1.01 times 10 to the power of 5 Pascal equals 101 kilopascal. Atmosphere pressure, ATM, is a cumulative force of the air molecules, which is referred to nitrogen and oxygen, that are attached to the Earth's surface by gravity. Next, we will learn on how to describe the major points of the kinetic molecular theory of gases. Kinetic is a study of rate of chemical reaction. 1. Gases are made up of small atoms or molecules that are in constant, random motion. 2. The distance of these atoms or molecules is very large, compared to the size of the individual atoms or molecules. In other words, gas is mostly empty space. 3. All of the atoms and molecules behave independently. No attractive or repulsive forces exist between atoms or molecules in gas. Next is 4. Atoms and molecules collide, and the energy is transferred with each other. No losing of energy involved during collision. 5. The average kinetic energy of the atoms and molecules is proportional to temperature. Gases also have other special properties such as compressible, will expand to fill any container, low density. Gas behaves ideally at high temperature and low pressure. Why? Because at low pressure, the greatest distance of separation among atoms or molecules, so minimizing interactive forces. At high temperature, atoms or molecules are in rapid motion, and are able to overcome interactive forces more easily, as the molecules gain energy to move randomly. Now, we move to the next topic on the liquid state. Molecules in the liquid state are closed together. It has large attractive forces to keep the molecules together. However, the attractive forces in liquid are not large as in solids to restrict movement. Let's look at the various properties of liquid in more details. First property is a compressibility. Liquids are practically incompressible. In fact, the molecules are so close to one another, and not significantly affected by atmosphere pressure. This makes liquids ideal for the transformation of force, such as the brake lines of an automobile. When we push a brake pedal, the force is transmitted directly to the brake pedal pads, and the friction between the brake pads and rotors, that are attached to the wheel, stops the car. Next property is a viscosity. The viscosity of a liquid is a measure of its resistance to flow. And it is the function of both the attractive forces between molecules and molecules' geometry. Viscosity is also affected by the polarity of that liquid. Polar molecules tend to have higher viscosity. Viscosity generally decreases with increasing temperature. At high temperature, it can fluidize the liquid. However, it also depends to the rheological properties of that liquid. For example, starch, if we use high energy, the viscosity will be increasing. So, here we can conclude that viscosity is very important aspect to design products such as glycerol, which is used in a variety of skin treatments due to its high polarity. Motor oils, transmission fluids found in automobiles, whereby temperature effect is very important consideration, because we need to ensure the liquid products remain fluid at low temperature. Okay, now we move to the third property of liquid, which is surface tension. The surface tension of liquid is a measure of the attractive forces exerted at the surface of a liquid. It is only the surface molecules that are not totally surrounded by other liquid molecules. Or in the simplest sense, it behaves as a skin that covers the interior. So, what is its function? It is responsible for the spherical shape of drops of liquids. Surface tension generally decreases with the increase in temperature, or a decrease in the polarity that make up the liquid. So, how to reduce its effect? By using surfactant, such as soaps and detergents. These surfactants can promote the interaction of water with grease and dirt, making it easier to remove. Next, we move to the property of vapor pressure of a liquid. It is defined as the pressure exerted by the vapor at equilibrium, as shown in this equation. This equation shows the particles of water in gas form, which equals to the particle of water in liquid form, at equilibrium state. Consider this example: you have a liquid of water, and pour into a sealed container. After a certain time, the container is analyzed. We might expect only liquid water in the container. However, in the closed system, some of the liquid water was converted to a gas, through evaporation, and some gas water converted back to a liquid, through condensation, when achieved at equilibrium state. Next, the other definition of boiling point is the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. The normal atmospheric pressure is 760 torr, or 1 atm. The normal boiling point is the temperature at which the vapor pressure is equal to 1 atm. The boiling point is not constant depending on the atmospheric pressure. Now, let's see the examples of water. 1. At high altitude, the boiling point below 100 degrees C. 2. At low altitude, the boiling point above 100 degrees C. Apart from its dependence on the atmospheric pressure, the boiling point also depends on the nature of attractive forces between the liquid molecules. For example, polar liquids such as water with large intermolecular forces have higher boiling points than non-polar liquids such as gasoline, which exhibit weak attractive forces. Now, let's move to the dipolar attraction in the liquid state, known as van der Waals forces. It is an intermolecular forces that affects the physical properties of liquid. It can be divided into London forces and dipole-dipole interactions. London forces exist among polar and non-polar molecules, while dipole-dipole attractions occur among polar molecules. In addition to van der Waals forces, a special type of dipole-dipole force, namely hydrogen bond, has a very significant effect on the molecular properties, particularly in biological system. Now, we will learn what hydrogen bond is. It is a typical force in polar liquids, and is defined as hydrogen atom that is bonded to electronegative atoms, such as nitrogen, oxygen, or fluorine. The presence of these electronegative atoms create a large dipole, means that the molecule is more polar. For example, like water molecules. The hydrogen bond is one of the strongest intermolecular forces, but weaker than a covalent or an ionic bond. It is interesting to note that the boiling points increase as the electronegativity of the element bonded to hydrogen increase. This hydrogen bond has an extremely important influence on the behavior of many biological systems. Molecules, such as protein and DNA, require hydrogen bond to maintain their structures, and hence functions. For example, DNA needs thousands of hydrogen bonds. Now, we move to the last state of matter, which is solid state. Solid has the strongest attractive forces to restrict motion. And the particles are locked together in highly organized fashion compared to other states of matter. Although it has fixed shape and volume, at the atomic level, vibrational motion is still observed in the molecules. Next, we go to the properties of solid. Solids are virtually incompressible, owing the small distance between particles. Most will convert to liquids, at higher temperatures, and at its melting points. The melting point is the temperature at which solid is converted to the liquid phase. However, it depends on the strength of the attractive forces in the solid, means its structure. Therefore, we can say that polar solids have higher melting points than non-polar solids of same molecular weight. Solids can be divided into two categories, which are crystalline solid and amorphous solid. Crystalline solids have a regular repeating structure and more organized. For examples, diamonds and sodium chloride. Whereby amorphous solids have no organized structure. As examples, glass, plastic, and concrete. Crystalline solids can be further divided into four general groups, which are ionic, covalent, molecular, and metallic solids. Let's start with the ionic solid. It comprises of positive and negative ions, and electrostatic forces hold the crystal together. Due to strong interaction of ionic bond, it has high melting points, and is hard and brittle. A common example is sodium chloride. Second type is a covalent solid. The atoms are held together by covalent bonds. Very high melting points, but not as higher as ionic solid. The solid is also extremely hard and insoluble in most solvents. A common example of covalent solid is diamond. Third type of crystalline solid is a molecular solid. The units are held together by intermolecular forces, such as London forces, dipole-dipole interactions, and hydrogen bond. Molecular solids are usually soft and have low melting point. They are frequently volatile and are poor electrical conductors. A common example is ice or solid water. The last of crystalline solid is a metallic solid that consists of metal atoms held together by metallic bonds. Metallic means the element in group 1 and group 2. Electrons in these elements are extremely mobile, resulting in high conductivity, or the ability to carry electrical current. The metals are easily shaped, and are used for a variety purposes, such as in hardware, cookware, surgical, and dental tools. Others are purely for enjoyment and decoration, such as silver and copper. As usual, let's relate this chapter with special topics on the connection of chemistry with environment and health. In an environment perspective, we will concentrate on the greenhouse effect and global warming. Greenhouse is mostly used in 4 seasons countries. A greenhouse has warm, bright, and humid environment for growing plants, vegetables, flowers, during the cold winter months. It functions as closed system, and creates an ideal climate for plant growth. The visible light is absorbed by plant and soil, and radiated as infrared radiation. This radiation energy is blocked by the glass, or absorbed by water vapor, and carbon dioxide. The trapped energy forms a solar heating. Similar in our Earth, carbon dioxide traps energy, radiated from the Earth's surface, and store it in the atmosphere. Since 1900, the atmospheric concentration of carbon dioxide has increased, due to the energy demands in technology, population growth, combustion or organic matters, and carbon-based fuel. Even in photosynthesis, removes carbon dioxide. Consequently, the increase in carbon dioxide levels will produce global warming. Now, we learn on a medical perspective of blood gases and respiration. Respiration is a process of delivering oxygen to cells, and waste product, carbon dioxide to the lungs to be exhaled. As we know, gases move from higher to lower pressure, for establishing an equilibrium. Since the atmospheric oxygen is high, and atmospheric carbon dioxide is low. Carbon dioxide from our body is removed from the blood, and oxygen from outside is moved to the bloodstream and gained by the cells. Oxygen is used by the energy harvesting reaction in the oxidation of glucose. The process is continuous. When we breathe, we take oxygen and distributes to the cells and used to generate energy. The energy is used to do all the activities. Then, the waste product of carbon dioxide is expelled by the lungs. However, high concentration of carbon dioxide and carbon monoxide in the atmosphere can cause a bad effect to our health. For recapitulation, students should be able to compare the gas, liquid, and solid states with regard to the following. 1. Average distance of particle separation. 2. Nature of interactions among the particles. Students also need to understand: why are gases easily compressible? Why do gases expand to fill any available volume? Distinguish the following term. 1. Evaporation and condensation. 2. Evaporation and boiling. Lastly, describe one property that is characteristic of the following. 1. Ionic solids. 2. Covalent solids. 3. Molecular solids, and 4. Metallic solids. We have reached towards the end of our lecture for this week. Hope you enjoy watching the video. Bye.